Hey everyone, let's take a quick look at number 13 in section 4.5. We're told to evaluate the limit. Now, of course, this is in section 4.5 on L'Hopital's rule, so we want to see if we can use L'Hopital's rule. Keep in mind, L'Hopital's rule works only on limits that are of the form what? 0 over 0 or infinity over infinity. Okay. Notice in this case, we're taking the limit as x approaches pi over 2 of secant x minus tangent x. So what's that limit going to be? Well, let's look at the graphs of these functions. They are on the help sheet. We got secant x minus tangent x. So let's take a look at it. Here's secant x. Let's look at, and of course, notice that secant x, here's pi over 2, right? We have a vertical asymptote there. Here's tangent, same thing. Both of those have vertical asymptotes. So what's happening is that, therefore, the limit as x approaches pi over 2 from either side, that's going to be an infinite limit. So let's look at from the positive side. So we approach pi over 2 from the positive side. Look at secant x. Where are we going? Up, 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 going to positive infinity. What about tangent x as we approach from, sorry, I said positive side. From the negative side, as we approach from the negative side, we're going to positive infinity. From the negative side here, positive infinity. So from the negative side, this is infinity minus infinity. What about from the positive side? So now, from the positive side, as we approach pi over 2, we're going where? Dropping down to minus infinity. Tangent, where are we going? Dropping down to minus infinity. So there we have minus infinity minus a negative infinity. Well, minus a negative infinity, that would be plus infinity, right? And notice that minus infinity plus infinity is the same thing as infinity minus infinity. So either way, we see this limit is this, which is indeterminate, but it's not L'Hopital's rule form. You can't just apply L'Hopital's rule, like take the derivative of that and derivative of that and subtract. That's not going to work, right, to find this limit. So what's going on? Some of you might say, well, infinity minus infinity, that's just 0. Well, that's not true. As you're approaching pi over 2, one function may be growing more rapidly than the other, so that infinity minus infinity could be infinity. Or they could be approaching infinity at sort of the same rate, but always being a fixed distance between each other. And then infinity minus infinity could be any real number. So what are we going to do? Well, the only thing I think we can do is simply rewrite and see if we can combine these two functions in some way. And what do I mean by rewrite? Rewrite them in terms of sines and cosines, right? Secant is the reciprocal of cosine. Tangent is sine x over cosine of x. And now I can combine these. Notice when I'm subtracting fractions, I need a common denominator. Well, guess what? We have a common denominator, so we're good to go. So I can just subtract 1 minus sine of x over cosine of x. So I just rewrite this by combining as one fraction. And now as I approach pi over 2, what happens? Sine of pi over 2 is 1, so 1 minus 1 is 0. Cosine of pi over 2 is 0, right? So guess what? We're L'Hopital rule form. So I have to do a little manipulation to get infinity minus infinity to be in this form. That's typically what you're going to do when you have that situation. You're going to combine them, as one fraction a lot of times. Okay, so now I can use L'Hopital's rule. Take the derivative of the top. Derivative of 1 is 0. Derivative of sine of x is cosine of x. So I get 0 minus cosine of x, or a negative cosine of x. Derivative of cosine of x is negative sine of x. And now notice I can plug in, right, pi over 2. Cosine of pi over 2 is 0. Sine of pi over 2 is 1, so I get negative 1. 0 divided by negative 1 is 0. And so in this case, infinity minus infinity is 0, but don't assume that's always going to be the case. Okay, so there is how you can use L'Hopital's rule to find this limit. Hope this helps.